In our last video, we went through an informal definition of deterministic finite state machines. This video will go through the formal definition for them, which will be useful for us later when we define algorithms that work with finite state machines. For this video, you should be familiar with the following fundamentals of set theory: what a set is, what a tuple is, the Cartesian product between two sets, functions and relations on sets, and you should have covered the previous video on finite state machines. It's actually very simple. The formal representation of a finite state machine is as a quintuple, a tuple with 5 parts: K, sigma, delta, S, and A. And you already know what each of these are. The first part, K, is just the set of the states of the finite state machine. So, for the machine that we discussed in the last video, K is simply the set Q0, Q1, Q2. You've probably already guessed what sigma is. It's simply the alphabet that the machine has to work with. So for our example machine, sigma is simply the set A, B. Delta is the most difficult part of the quintuple representation. It represents all of the transitions in the diagram and is a function from the Cartesian product of K and sigma to K. So, let's build up a few elements of delta for our example machine. So, for the transition that I've just marked there, the element of delta will look like Q0 with an A, we transition to Q1, and is represented as a tuple like so. Sometimes we might simply represent it as the state symbol pair and then an arrow to the state that the transition takes us to. This transition here, whilst it looks like one transition, is actually two. Q2 with an A goes to Q2, and Q2 with a B goes to Q2. There must be an element in delta for every state and every symbol for every state. I've included here the full transition function for our example machine. You might like to pause the video here and make sure you understand everything that's going on. The next element of our tuple is much simpler, S. S is simply the start state of the machine. So, for our example machine, S is simply Q0. The final element of the quintuple is the set of accepting states. A is a subset of K. Again, for our example machine, A is the set Q0, Q1. To bring it all together, the quintuple representation for our example machine is simply the following: set of all states, the set of symbols that the machine has to work with, the alphabet, the start state, Q0, and the set of accepting states. Delta, because it would make the quintuple representation look incredibly messy if we included it in line, we often write separately. So, having watched this video, you should understand what the quintuple representation of a deterministic finite state machine is, and how to convert between the tuple representation and the state transition diagram of a particular machine. If you want more information, you can see section 5.1 of your textbook.